Imagine a world where Tyrannosaurus rex roamed the land, towering above the ferns and cycads, their thunderous footsteps echoing through ancient forests. But while these giants ruled the earth, in the rivers below, a remarkable ancestor of today's salmon was quietly swimming, adapting to a world in constant change. Scientists recently uncovered a 73-million-year-old fossil in Alaska, revealing the oldest known member of the salmon family, Sivulliusalmo alaskensis. This ancient fish lived at a time when the continents were still shifting, and the climate was far different from today. This discovery pushes the salmon family's origins back by over 20 million years, rewriting the story of their evolution and showing us that salmon have a much deeper history than we ever realized. Before this, the oldest salmon fossils were only 50 million years old, leaving a huge gap in our understanding of how these fish evolved and spread across the globe. The fossil's discovery in Alaska's remote North Slope was a rare stroke of luck. Fish bones are fragile and seldom survive the ravages of time, especially in such harsh and unforgiving environments. Yet, this ancient fish endured, its bones preserved for millions of years, offering a direct link between the age of dinosaurs and the salmon we know today. It's a tangible connection to a world long vanished. It's a reminder that beneath the dinosaurs' feet, rivers teemed with life, complex ecosystems that shape the future of entire species, including the ancestors of modern salmon. This salmon ancestor swam Arctic rivers, while dinosaurs walked the earth carrying the genetic blueprint for a family that would one day span the northern hemisphere from the Pacific to the Atlantic. The find forces us to rethink salmon's evolutionary journey and the hidden stories still waiting in the rocks. Stories that challenge what we thought we knew about life's resilience and adaptability. It's a powerful reminder that life's story is full of surprises, and that every new discovery can change our understanding of the past. The ancient world was more interconnected than we ever imagined, with rivers acting as highways for evolution, linking distant lands and species. And sometimes, the smallest fossils tell the biggest stories, reminding us that even the tiniest creatures can leave a legacy that endures for millions of years. For decades, scientists believed salmon first appeared in the Pacific Northwest about 50 million years ago. This idea shaped our understanding of how these iconic fish evolved and spread across the region's rivers and streams. All the oldest fossils pointed to this region and era, until Sivulliusalmo alaskensis changed everything. This remarkable fossil, unearthed in the far north, forced scientists to rethink the entire timeline of salmon evolution. At 73 million years old, this fossil is a game-changer, pushing the salmon family's roots deep into the age of dinosaurs. It means salmon were swimming in ancient waters while massive reptiles still roamed the earth. This isn't a minor update. It's a massive rewrite of salmon history. The discovery has sent ripples through the scientific community, challenging long-held beliefs and sparking new debates. The discovery means salmon had a much longer, more complex evolutionary journey than anyone realized. Their story stretches back further with more twists and turns than previously thought. It opens new questions. Where did they spend those extra 20 million years? What environments did they adapt to? And what challenges did they overcome during that lost time? What other ancient relatives are waiting to be found? Each new fossil could reveal another chapter in the salmon family's incredible saga. The fossil's Arctic origin challenges the idea that salmon began in mild climates. Instead, it suggests these fish may have first evolved in places few would expect. Instead, their story may have started in a place of extremes, long dark winters, and constant environmental challenges. Surviving in such a harsh world would have shaped their resilience and adaptability. This single fossil points us toward a colder, more surprising origin for one of the world's most iconic fish. It hints at a lineage that thrived in icy waters long before humans ever saw a salmon leap. It's a clue that the cradle of salmon evolution may have been the ancient Arctic, not the temperate Pacific Northwest. The migration routes we know today might be echoes of journeys that began in a frozen, forgotten world. The story of salmon is far older and far wilder than we ever imagined. Their journey is a testament to survival, adaptation, and the mysteries still hidden in Earth's deep past. Sometimes, one discovery is all it takes to turn science on its head. Sivulliusalmo alaskensis is a reminder that the past is always waiting to surprise us. And now, the search for more ancient salmon relatives is just beginning. Who knows what other secrets lie buried beneath the Arctic ice, waiting to change our understanding of life on Earth. Today's Arctic is icy and barren, a vast expanse of snow and ice stretching as far as the eye can see, seemingly inhospitable to most forms of life. But 73 million years ago, this frozen wilderness was transformed into a lush forested world, teeming with vibrant life and dense greenery. Alaska was blanketed in conifers, ferns, and flowering plants, creating a thriving ecosystem that would be unrecognizable today. There were no polar ice caps in sight, just endless stretches of green, where ancient rivers and lakes supported a diversity of life. The region's extreme seasons, months of darkness followed by endless daylight, created a unique and challenging environment for any creature that called it home. Sivulliusalmo alaskensis, an ancient ancestor of salmon, thrived here, revealing that the Arctic was more than just a refuge from harsh conditions. It was a true cradle of evolution and adaptation. This remarkable discovery challenges the long-held idea that biodiversity always begins in the tropics, showing that life can flourish in unexpected places. The ancient Arctic's dramatic cycles of light and darkness may have protected new species from giant marine predators, giving them a rare chance to evolve in relative safety. In these waters, adaptable fish like the ancestors of salmon could diversify, experiment, and thrive, taking advantage of the region's isolation and unique conditions. The Arctic wasn't a barren outpost at all. It was a dynamic laboratory for life, where new forms and strategies emerged in response to the environment's extremes. The resilience of the salmon family was forged in this crucible of extremes, shaped by the challenges and opportunities of the ancient Arctic. Sometimes it's the harshest and most unlikely places that spark the greatest evolutionary leaps, reminding us that life's story is full of surprises. Surviving the ancient Arctic meant enduring months of sunlight, then months of darkness. Sivulliusalmo alaskensis likely adapted with a remarkable toolkit migration, metabolic slowdown, and predatory skills. In summer, it may have fed in rich rivers. In winter, it could have migrated to the ocean or entered a near hibernation state. Modern fish in cold climates use similar strategies to survive when food is scarce. The fossil's powerful bones suggest it was a strong swimmer, able to navigate swift currents and hunt smaller fish. These adaptations, migration, endurance, and resilience, are still seen in salmon today. The ancient Arctic shaped a fish built for survival. Sivulliusalmo's story is one of adaptation and endurance. Its legacy lives on in every salmon's epic journey. The past's challenges became the future's strengths. Sivulliusalmo alaskensis wasn't alone in the ancient Arctic. Its fossil was found in Alaska's Prince Creek Formation, a treasure trove of late Cretaceous life. Rivers teemed with fish, relatives of pike, smelt, and more, while forests hosted unique Arctic dinosaurs like Nanuqsaurus. Every species, from plants to predators, adapted to the polar extremes. The ancient salmon was part of a vibrant ecosystem, supporting and supported by others. Freshwater rivers were productive enough to sustain diverse life, including hungry dinosaurs and swooping pterosaurs. Sivulliusalmo's presence reveals how interconnected and dynamic this polar world was. The Arctic wasn't just a land of dinosaurs, it was a thriving, complete ecosystem, and the salmon story is woven into its very fabric. Studying a delicate fossil like Sivulliusalmo alaskensis is a challenge. Its tiny bones are hidden deep in rock. Traditional methods risk destroying the very features scientists needed. Enter microcomputed tomography, or micro-CT scanning, a technology that lets researchers see inside the rock without touching the fossil. Thousands of X-ray images are combined to create a detailed 3D digital model. Scientists can rotate, zoom, and even digitally dissect the fossil, revealing every bone and groove. This non-destructive method preserves the fossil while unlocking its secrets. It's like having X-ray vision into the ancient past. Technology turned a fragile fossil into a window on evolution, and it's changing how we study life's oldest stories. Micro-CT scans were crucial in confirming Sivulliusalmo as a salmon ancestor. The technology revealed delicate skull features that traditional methods might have destroyed. Digital models can be shared worldwide, letting scientists collaborate instantly. These models are preserved forever even if the original fossil is lost. 3D prints and animations bring ancient creatures to life for students and museum visitors. Technology transforms fossils from static objects into interactive learning tools. Paleontology now blends fieldwork with advanced imaging and computing. This partnership is revolutionizing our understanding of the past. Sivulliusalmo's story is proof. The future of discovery is digital, and every new tool brings us closer to the secrets of ancient life. The story of Sivulliusalmo alaskensis is more than ancient history, it's a lesson for today. The Arctic is warming rapidly and salmon face new challenges. This fossil shows that life can adapt to dramatic environmental shifts, but only over long timescales. Modern climate change is happening much faster than in the past. Salmon's resilience is rooted in their evolutionary history, but today's pressures are unprecedented. Studying ancient survivors helps scientists predict which species are most vulnerable now. The fossil record is a guide, not a guarantee. Conservation efforts depend on understanding both the past and the present. Sivulliusalmo's message adaptation takes time, and time is running short. The ancient salmon story is a call to protect the future of life on Earth. Sivulliusalmo alaskensis reminds us that nature's story is always evolving. One fossil can rewrite what we thought we knew about a familiar animal. Salmon are not just river fish, they're survivors with roots in the world of polar dinosaurs. This discovery challenges our assumptions about where and how life evolves. The ancient Arctic, once seen as barren, was a cradle of innovation. Every living creature carries a history millions of years deep. When you see a salmon leap today, imagine its ancestor dodging dinosaurs in an Arctic river. The past is alive in every survivor. Sivulliusalmo's story is about discovery, resilience, and the power of curiosity. And it proves the next big chapter in life's story could be just one fossil away.